Greetings all. We're up to grade 5, part 1 of the hardest math problems show you work. There's a whole bunch of other versions for other grades and multiple choice, which you can find at GregsTutoringNYC.com/hardest-math. The link is at the bottom of the white part there. My email is also at the bottom. Anybody who needs any other questions answered in ELA, science, tutoring, even computer stuff. I do lots of tutoring for lots of subjects, and right now we're concentrating on the hardest math problems for grade 5. Okay, so without further ado, I'm going to jump right into it. These run about an hour. If you're catching this on the replay, you can hit pause and try to answer the question yourself, which focusing on concepts here in addition to the actual solutions, plus just general skill comments that I can offer you guys for answering questions without getting points off or something like that. But the main thing we're trying to focus on is what exactly is the math concept and the math topic that they're trying to give you here. I'm sourcing these from the New York State tests, where whereas a lot of kids got the question wrong. A lot, I don't mean a couple hundred, I mean a couple 100,000. All right, because a lot of kids take those exams over the course of many years. And these are the problems that kick out a lot, especially on the multiple choice. I cherry picked. On the show your work section, I'm actually going to solve them all for each of the exams that they've made available because the students did so poorly on them. All right, so we're on grade 5 now. So if you were following any of my previous grade materials, all those concepts are still true. So you still need to know the multiplication table. You'll still need to be reading the directions properly. You'll still need to be bumping up your numeracy game, all these kind of things like that. So as we talk about them, you'll notice some of the concepts are different and some are the same. So we're just building upon as each grade goes along into the new topics that they're teaching. We're not building upon necessarily acceleration, and we're not necessarily building on complexity. However, that's generally speaking how the progression through the grades work. You know, normally you need to do addition first to figure out what multiplication is, and then you move from multiplication into, you know, squaring things and getting the square roots and figuring out division and so on. So there's this so-called natural progression, but some things can plug and play in various parts. I mention that because there's the notion of grade level math, and actually it's only grade level to the extent that the standards are saying they're 5th grade does a certain thing and 4th grade does another thing, but generally speaking, that's not really a real thing. Okay, and it's not age-based per se either. In any event, this is the progression we're taking, and this is what we're using for this decision of what the hardest math problems are to use. Okay, so question number 50. Let me show you my pen is okay. Yes, it's good. Write 203 and 42 thousandths in standard form and expanded form. So they actually give us those two choices at the bottom here. If you notice, in all the other things, there was a boldface, show your work. They wrote show your work about right there in boldface. This doesn't say that. So technically, this is just a scrap space for you guys to do it. I pointed out in some of the other grades that it may have asked the question and it said to explain it. Okay, and a lot of you guys lose points by not doing the explanation. Or when you give the explanation, you make it too static, like 1 + 1 = 2. The explanation of that is not 1 + 1 = 2. You have to talk about what addition means and so on to actually get credit for the explanation. So in this case, there's no show your work. So basically, all they want you to do is write those two forms. So we have to know what a standard form means and what an expanded form means. Okay, those are the two gotchas here. All right, so standard form is just the number. Like if I say 1, 2, 3, that's the standard form of the number 123. So to be clear, this is 100. And for those of you starting the series off here, I often do little sidebar conversations. 123. And notice for those starting off at this point too that my handwriting is atrocious. Notice that I did not put the word and here. Okay, and normally implies addition or fractions, which is what we have up there. Okay, so be careful. And let me just give me 1 second. So I want to make sure the screen is showing for you guys and that we're going to be okay. We're going live. For these grade levels, I'm not allowing the chat to be available. We're going to do those in later grades. All right, let's see here. Let me bring that tab back because the screen looks all right. So there is no word and. 100 and 23 is that. Okay? So the full word we're going to get here is 203. Right? 203 and implies our decimal point there. 42 thousandths. So just like this is the ones, this is the tens, and this is the hundreds, we go the same way. This is a tenth. If I put X there, the Y would be 100ths. And if there was a Z, that would be 1,000ths. So that's the word we're using there. That means we need 3 digits involved. So we have the 42, we add a 0. So that's the tenths, hundredths, thousandths. So that's our match for that. Okay? Okay? The expanded form is to take the place value, because that's what's being tested here. In addition to knowing the forms, we're talking about place value, right? Because we can even rip this apart, even not even involving the decimal part. So this was 200. This 2 is not a 2. This is in the hundreds column. So this is actually 200. This is 0 tenths and 3 ones. So that is the expanded form. Okay, so we're going to have 200 or 2 times 100, right? Plus no tens plus 3 ones. Okay, that's what they're looking for that kind of a thing there. And then there's the and, right? So we can put a plus there. There's no, let me change the color of that, just so you guys are clear what we're talking about, which side is the fraction side and which side is not. And 0 tenths plus 4 hundredths, right? THS. And we can use a multiplier there. Plus 2 thousandths. Okay, so this is the expanded form here. And this here is the standard form. That's all they're looking for in this answer. They're not looking for anything else. So again, this is really about place value. It's about mapping words, the English words, into standard form, mapping English words into expanded form, or if you want, taking the digit, the standard form, and put it into the expanded form. There's a slight variation to this, which is going to be 200. And we can leave the 0 out if we want, or we can put it in plus 3 plus, we can leave that out theoretically too as well. And then we get 4 hundredths plus 2 thousandths. Okay, and we normally leave it this way. We know we can take this and simplify it, but we normally leave it that way. Okay, so just to take a little sidebar, this is the same as 1 over 500. If they ask you to simplify it, they're not going to in this kind of example. And this would be 1 over 25, right? I'm not going to explore That here I'm just I can't take too many sidebars. I'm still trying to answer question number 50, but I'm just adding these as extra stuff. If you can't figure that out, please email me. My email is at the bottom of the screen, GregsTutoringNYC@gmail.com. All right, I'm just adding extra stuff for food for thought. These extra stuff at the moment has nothing to do with the question. I'm just throwing out extra stuff that you should be knowing at grade level 4. All right, so again, this is about standard form, expanded form, place value, and because it involves a decimal, right? We had the decimal here. Where's my tablet again? I lost. The cursor's gone. Where's the cursor? There it is. It involves decimals, right? Because we have the decimal point there. All right. So in math, we don't call that a period. That's a decimal point. And again, this did not say show your work. So theoretically, you don't lose points for not showing any work in this example. That's kind of oxymoron since we're in the show your work section here. But so this is really a decimal question, a place value question. All right. That's what we're talking about. And place value, again, deals with if it's this one was hundredths. That's in the hundredths column. This is in the tens column. That's in the one column. This is the 1/10th column. This is the 100th column. This is the 1000th column, right? Those are things you should know in this grade level, okay? Okay, 51. Tony began. Okay, so we're going to look at the illustration. I'm not quite sure what's going on here. So we have 1, 2, 3, 4, 5, 6 coming down that way. And we have 1, 2, 3, 4, 5, 6, 7 going down that way. I don't know what it means. There's actually 12 things there, though, right? Because this square here that I'm going to put an X in was counted twice, right? There's 5 here. I can go 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 11, and then add this one in here. Gives me 12, right? So let me get rid of some of this because these don't necessarily have anything to do with the question, as far as I know. And I'll leave it at that. I'm going to leave the 7 and the 6 on the sides there because they may ask us to maybe I'm feeling they're going to ask us to fill this in as something like that. Okay. And I'm not sure what the sun about there. It looks like a jigsaw puzzle or something. In fact, that word is throwing out at me, so I already do know it is. So on that, let's go look at the words. Tony began putting together a rectangular puzzle. All right, so there is going to be pieces there. He completed the top edge, which is the 7 pieces there, and the left edge, which is the 6 on the side, okay, as shown below. Each piece is a square that is a length of 2.5 by 2.5. So they're saying that each unit square here, that if I was to basically take a bird's eye view of it, right, has 2.5 centimeters there, and it's a square, right? So 2.5 centimeters here, 2.5 centimeters here, and 2.5 centimeters there. And they're asking now, what is the total area in square centimeters of the completed puzzle? So first of all, each side of the square was in centimeters, so we're cool, and they're asking for centimeters. So the first thing we want to know on something like this is, do we have to do unit conversion? Like, do we have to convert centimeters to meters or centimeters to feet or something like that? No, we don't. That's not involved here. The second thing we're going to do is look and see if there's a key or a legend. Okay, there's not. However, they've given us this sentence here. So that's as if they gave us that, because they could have put in here that this is equal to 2.5 centimeter square unit. Okay, so instead they use words. So that's cool. All right. So now what we need to do is they're asking what is the total area of the completed puzzle. Okay, So you should be able to determine that since this is a 6 by 7 array, it's called, because this, if we filled all these in, that's what we would end up with. 6 times 7 is 42. So this is tapping into knowing your multiplication table again, which you guys should know up to at least 10 by 10, if not 12 by 12. And for those of you who really wants to push the envelope, go to 20 by 20. Okay, that's a nice goal to kind of go into. So what we have is there's 42 unit squares. So I'm just going to put U square. But a unit is this 2.5 squared thingy. All right. So what we need to do is go through and now multiply some of that out. Okay. So it means we have 42 times 2.5 is what we need to do. Okay. So we can kind of do that a couple ways. We can double the 42 and get 84, and then we can add to that a half of it, which is 21. So that would give us 105. Okay? So that's 42 times 2.5. We could also go and do 42 and multiply it by 2.5. Okay? 5 times 2 is 10, 0, 1, 21. We get 4 and then 8. Okay? We get 0, 5, 1, 0. We had no decimal points on the 42. We had 1 here. So we take this and move it here. And in both scenarios, if you notice, we get the 105. All right? There's one problem with that, is that we only compensated for one side of the length of this here. We also have to compensate for another one. Let me change the color of this one more time. Right, we have to compensate for that. These are units squared. So we only did one side, we have to do the other. So it means we need to take that 105 and also multiply it by 2.5. Okay, we can use the same initial strategy we did here and double it. That gives us 210, right? And then take half of it. Half of it is 5250 or 52.5. And if we add the two of those, we get 262.5. Okay? Or if you don't want to use that strategy, we can do the 105 times 2.5 and multiply that out. So if you notice, this is testing your multiplication fluidity and no hesitation and mastery to the max here. It's no matter which way you do it, it's really testing you. So let's see. 5 times 5 is 25. Carry the 2. 5 times 0 is 0 plus the 2. 5 times 1 is 5. 5 times 2 is 10, 0. Replace the 2 with the 1. 2 times 0 is that. Put the 1 down, and then 2 times 1 is 2. Right, so we get 5, 2, 6, 2. Okay, and we have, again, the 105 had no decimal, but the 2.5 had 1 decimal. So we're going to take the decimal, move it once, and we get 262.5 no matter which way we've done this. All right? And that turns out to be the answer, 262.5. Okay? There was still another way to do this, because if you notice what we're actually doing, let me try to scroll this and try to keep this here at the same time. Basically what we did was we took 42 and we multiplied it by 2.5 times 2.5. All right? Another way to do this was, you know that A times B is the same as B times A. And you also know that if it was A times B times C, we could, whoops, I didn't put the B in there. We can also do that as A times C times B. We can also do it as B times A times C, B times C times A, and C times A times B, and C times B times A. You can replay that back if you guys want to get that. Okay? So what it means is we could have multiplied the two of these together first. Okay? So if you know your perfect squares, you should know what 2.5 times 2.5 is. Right? If you know 25 squared, you're going to get 625. So let's see if we can get that out. Remember, there's a decimal point here. So you're going to have to move a decimal point once you do that. So 5 times 5 is 25. carry your 2. 5 times 2 is 10, 12. Okay, and I know some of you do double-digit multiplication, slightly different than the technique I'm using here. I can't show every possible technique. So 5 times 2 is 10, 0. Carry my 1. 2 times 2 is 4, 5. Okay, so I get that 625 I was talking about here. And I have 1 decimal point here, 1 decimal point here. So I'm going to move it twice. So this is equal to 6.25. Okay, and then what I have to do is the 6.25 times the 42. So if you notice, no matter which way we do this, we have a lot of whacked out multiplication. And I'm going to do this right here live. I normally avoid these when I'm doing it live because I don't want to make a mistake in front of you guys. But let's see how it goes. 5 times 2 is 10, 0. Carry the 1. 2 times 2 is 4 plus 1 is 5. 6 times 2 is 12. Okay, 5, let me write that 12 so I don't add it wrong later. 5 times 4 is 20, 0. Carry the 2. 4 times 2 is 8, that's 10, 0. Carry the 1, 6 times 4 is 24, that gives us 25. Okay, and if we add that up, we get 0, 5, 2, 6, 2. We move twice here, so we move twice again. And we get back our 262.50. Oh, yeah. All right. So I was able to figure that out and do that. Okay. So if you notice, I did this 3 different ways just to show you that there's variability and know how you solve it. And if you know, if you're comfortable doing like the 2.5 times the 2.5 and knowing that's 6.25, or if you're better off, if you know, if you can do the 105. 0.2.5 this way here, or if not, then you do it that way. So it's not really a big deal. Anyway, this is showing that there was kind of multiple steps involved in the showing you work, right? Don't just do the 42 times the 2.5, and that has kind of 2 whammies. First of all, some students think that's all you have to do, all right? The second thing is you may realize you have to do the 2.5 twice, multiply it twice, but forget when you're trying to solve the problem. You get so engrossed in solving the problem that you forgot what you were supposed to do. All right? So be careful. Remember, area deals with squaring. Area is a square units. So you just can't evolve one part of it. You have to evolve both parts of it. Okay? On the same note, there's still another way to do it, which is to take the 6 and the 7 by themselves and get the 2.5 thingies in there, multiply them out properly, and then whatever you end up after doing the 2.5s twice, multiply that back out too. I'm not going to show that, but that's also possible as well. In other words, we could have taken 2.5 of the 6, right, and that would give us 15, and 2.5 of the 7, which would give us 17.5, right? We can multiply out those numbers, and that will still give us the 262.50. All right, it's interesting how all this can work. All right, and by the way, that's a way to double check your answer by doing it a completely different strategy, and make sure that when you were doing the multiplication table, that it was there. So this was the valve in the multiplication table. It was involved doing multiple parts to the solution, no matter how you did it. It was a multi-step question. It was also, no matter how you did it, it was multi-digit times multi-digit. Since this involves an illustration, which is it's geometry, it's area, and this word I talked about, it could have been as a key, but in this case they use words. This it was scaled. This is at a scale, a 2.5 scale, right? Okay, so this involves scale as well. And depending on how you look at it, it involves fractions and or decimals, right? So this problem was all over the place, all right? Just totally all over the place. Okay, this one also builds on things. It's a word question. So 4 classmates are asked to decorate 1/5 of the bulletin board. 4 classmates are asked to decorate 1/5. So imagine we had a bulletin board. And we could split up different ways. We could split up that way. But let's just view it linearly for simplicity of talking about it. Okay. If we divided it into 4, okay, 1, 2, 3, 4. That was the bulletin board. Look at what's going on. They're asked to decorate 1/5 of it, though. They're each not being asked to decorate 1/4 of it. Or are they? So let's read further. So 4 classmates were asked to decorate 1/5 of the bulletin board. So that's here. So basically what it means is, let me change the color. 1 second. I'm going to kind of leave that there, but I'm going to put an X next to it. That's not what they're looking for. Basically, we have the bulletin board. And there's 1/5 of it. So let me try to get that into fifths correctly. 1, 2, 3, 4, 5. Let's assume these are all equal parts. So A, B, C, D, E. These are all 1/5 equally. Okay? So they divide the section to be decorated equally among the 4 classmates. Whoa, this is heavy. So they're saying A itself, if we were to look at A by itself, A is split into 4 parts. Wow. All right? Okay, you got that? What fraction of the entire bulletin board did they decorate? So we can put that in English, right? The bulletin board's already in fifths. So they're going to decorate 1/4 of 1/5. And that ends up being 1/20th. Okay? That's the most direct way to solve this. The other is to say that the bulletin board is in fifths. Okay? We're going to take a fifth and divide a fifth by 4. Right? Well, you guys should know that any number is itself over 1. So 4 is the same as 4 over 1. Okay? And then you should also now know that if we take this here, division by a fraction is the same as multiplication by its reciprocal. If I have 4 over 1, its reciprocal is 1 over 4. Okay? And we end up back with the same expression, and that gives us 1/20th. And that's what they're looking for, the 1 over 20. So this question also deals with knowing your multiplication table, also knowing that, so the answer, knowing how to multiply fractions, okay? And theoretically, you could have said 1/20th is the same as 5 100ths, so that's also, okay, you could have said that was the answer, but that's not what they're looking for here. You're not going to lose points if you said that, but you've gone too far. They're just saying, what fraction? All right, so that's a fraction. So read what's there. They're giving you a hint. They're not asking you to do anything with that. That doesn't get simplified. This and this are not simplifications of 1/20th. They're alternate forms of 1/20th. Right? Some simplifications are also alternate forms, but in this case, 5 100ths and 0.05 are not simplifying 1/20th. They're just alternate forms of it. Okay? So we have reciprocals. Remember, division by a fraction is multiplication by its reciprocal. That's one of the main things of this. The other was to realize the equal parts. There's kind of 2 levels of equal parts. One is the bulletin board is in fifths. And then out of that fifth, there's 4 classmates going to do stuff with it equally, right? Equally. Right? So that's how we know that, first of all, if they're in fifths, we know that these are all equal, and then we know each quarter inside of here, right? These are quarters of the fifth, right? Remember this whole little rectangle right here, that was A, right? I blew it up here. All right? So another way to look at this, if we made B also in 4 parts, and then C in 4 parts, and then D in 4 parts, and then E in 4 parts, what we have is 5 parts up here that we split each of them into 4 parts. Well, 5 times 4 is equal to 20. So if we would actually split each part up into the 4 parts, we'd have 20 parts. With the 4 classmates, right, each of them did 1/20th then. And we're not worried about B, C, D, or E. We're only worried about A in this case. Or one of them. We could have chosen C if we wanted to. Just whatever fifth we were looking at, that fifth was split further down equally among 4 classmates. Right? And that's all this question is about. All right? So there's that. So this is about equal parts. Twice. There was 2 levels to it. So again, this is a multi-part question. Okay, this one is just really confusing to a lot of kids. So let's go through it kind of. So the list below shows the numbers of miles John biked each day for 12 days. So that implies there should be 12 numbers here. 1, 2, 3, 4, 5. And I'm just trying to understand what's going on here so far. 6, 7, 8, 9, 10, 11, 12. Yep, there's 12 numbers. So each of those represents a day. Make a line plot. A what? Of the data using the line below. Include a title and correct labels. A line plot is not a number line. Okay, it is not a number line. A line plot is showing the distribution of these numbers in some fashion. Okay, in this case, I believe there's no empty spaces, so we can use a number line to represent it. So what we want to do is find the smallest number within here, the min number. So the smallest number seems to be 6.5. Okay, right? And then what we're going to do is start building up from there. And as we use a number, we're going to cross it off. So I have a 6.5 here, okay, and I'm going to put an X over it, okay. I have another 6.5 over here, so I'm going to put a second X there, okay. Now I'm going to observe the numbers, and it seems like the next smallest number is 6 3/4. And by the way, this 6.5 is 6 2/4. Okay, so let's go 6 3/4. We have one of them. We have a second one here. There's another one there. And there's actually another one there. I skipped that. Okay, so there's 4 of those. Okay, so if I went from 6 2/4 to 6 3/4, how about we look to see if there's a 7, and I see a 7. So I'm going to put this down 7. There's 1 there. And I'm going to do this one at a time so I don't miss one. There's a second one here. Or if I miss one, I can still go and find it. I have 7 1/4 left. I have 7.5 left. I have 7.5 left, 7 3/4. So I just noticed there was a 7 1/4. I think I'm done with the 7s. Okay. Where was that? There was 7 1/4 here. So there's 1. That seems to be it. There's a 7.5, which we know is the same as 7 2/4. Okay. So we're going to get rid of that. So we're going to put an X for that. There's another 7.5 here. So we're going to do a second one. And I think the only one left is 7 3/4. And that's the one there. And if we look at the number of X's, I'm going to change the color of the pen for a second. They're not asking you to do this, but I'm just verifying. I have 1 X here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've accommodated for all of the parts of this list shown here. It's a set of numbers. So let's look at it again and see if we've answered the question. The list below shows the number of miles John biked each day for 12 days. Okay? Make a line plot of the data below. Include a title and correct labels. Okay? So these right here are the labels, and we need to include a title. Your title can be down here. But usually you're better off putting at the top up here. Okay? So your title could be Miles John biked. And since you know what a line plot is, and if you didn't, now you do, you can actually look at this. I can say, was there any day, and if you want to put it, you can add on to, say, for instance, per day. So if I want to ask, were there any days that John biked 8 miles? No. The answer is no, it's not there. Were there any days John biked 6 3/4? Yes, 4 of them, right? So that's the beauty of that. And by the way, the analogous representation of this is normally your histogram, right? You might have a certain thing, and you would just shade them in that same number of things. Okay. I'm not trying to map the same numbers there, but and over here you would have 0, 1, 2, 3, 4, 5, 6, or whatever. All right. So this would be miles, right? And then you'd have days, and you could flip it depending on how you're viewing it. Okay. And remember, these days here in this form, they're not talking about Monday, Tuesday, Wednesday, Thursday, or whatever. In fact, it doesn't even say these are sequential or linear. So we could have biked the 6 3/4 today, and then two days from now, he biked the 7. It's only recording the 12 that he's interested in. All right? So there's that. So this deals with knowing what a line plot is. If you don't know what a line plot, you're totally up the creek. If it was just, in other words, if it was just a, it was just a number line, you would have done the 6 1/2 and maybe put a dot there. You would have done the 6 3/4 and put a dot there. You would have done the 7 and put a dot there. But then when you came across the same number again, what are you going to make a larger dot? Right? That's not really how it works. So some students feel that as long as you accommodate the 6 1/2, the 6 3/4, the 7, that's 3, 4, 5, these 6 different numbers, and you put 6 different dots, that would be the answer. It's not. That's not what a line plot is. So that's why it doesn't really work out. Okay. And in some ways, this is about the distribution of equal parts, but this is kind of not really an equal part question. So, but they are distributed out. So there's that. Okay, so that was 53. This is really about visual representation of your data and getting it right in a certain way. Okay, 54. A lot of kids got this one wrong. Let me take a sip for that because my throat's going out, and this is a busy question. If I remember this one right. Bella has 6.3 kilograms of berries. Let me make this a slightly darker pen. Give me 1 second. Let me just use brown at that note. She has 6.3 kilograms of berries. She packs 0.03 kilograms of berries into each container, right? She then sells each container for that certain amount. How much money will she earn if she sells all the containers? So this is somewhat confusing because we need to figure out how many containers. I could just write container, question mark, how many, right? We don't know how many, so we're going to have to figure that out first. All right? So if we divide the weight of each container into all the berry weight, right? And by the way, again, let me slightly bring this down so I can do this. This is kilograms, and that's kilograms. Again, there's no unit conversion, right? Everything's in kilograms, and there's no other problem. So when you set up a problem like this with the decimals, you often want the outside number, the divisor, to not be in decimal form. So what we want to do is multiply it by 10. If we do that, we multiply the inner number by 10. And one more time to get it to be 35. And if we do that, we have to add a 0. So what we basically end up getting is 35 divided into 630. Okay? So there's two things. First of all, my tablet battery is ready to die. Let's see what we have here. Well, let's see if we can get through the next few problems, because I think there's 3 more. If not, we'll do a part 2. SHPACs. So the first thing is getting this right, even with the decimal. Think it through. The total weight is 6.3. Each container is going to be 0.035. So if we get the unit price, if you will, the unit weight, if we divide that into that, we're going to get the number of containers. All right. So 35 goes into 6. It doesn't. 35 goes into 63 one time. So I'm going to do this as long division because of the remainder. So that's 5, that's 1, that's 8, that's 2. We drop down to 0. So now we get 35 into 280. I noticed that 35 times 2 is 70. And 70 times 4 is 280. So this must be 8. But I can come along the side and test it. 35 times 8. 5 times 8 is 40. 0 count the 4. 8 times 3 is 24. Plus 4 is 280, right? So I get 18. So this is 18 containers. Okay. So the answer is not 18. Especially if you go to the answer here, the answer is going to be in dollars. Okay. So there's 18 containers. It's telling us each container sells for $2.99. So what we need to do is $2.99 times 18. So again, it's testing the daylights out of our multiplication skills. 8 times 9 is 72. Carry the 7. 8 times 9 is 72 plus 7 gives us 79. Did I do that right? 8 times 2 is 16. Plus the 7 gives us what? 23? If I did that right. Okay. And then 1 times 9 is 9. 1 times 9 is 9. 1 times that is 2. Okay, hopefully I didn't make a mistake here. 2 plus nothing is 2. 9 plus 9 is 18. Carry the 1. 9, 10, 3, 1. 4, 3, 43, 82. Nope, I made a mistake. That was 2 plus 2 plus the 1 here. So this is 53, 82. Okay, and I can put a point there. That's my dollar amount that I'm looking for there. All right, so this was about decimals, decimal division. It was about a whole bunch of multiplications. And multi-digit multiplication involving decimals, right? So not only did we have to do the division here in decimal, but we had to do this multiplication of decimals. So just to be clear how I got the point here, there was no decimals in the 18, and the 9 I went over 1, 2. So I do that with the answer I got 5382, go 1, 2. Okay, whoops, wait, something's freaking out there. 1, 2 to give us that, okay? So that's how you do your triple digit times 3 times 2-digit multiplication with a decimal, all right? And this is about knowing your operations as well. You could have done a slide estimate once you realize you got 18 times 299. Okay, you could have estimated that to be 20 times 3. Okay, so that at the max, you're going to end up getting 60, right? This is an estimate. So it doesn't need to be like 53.5 or something like that. So that's my estimate that I didn't want to go over that, all right? Okay, so that's 54. Let me see if I can do this without the tablet battery dying. Wait, did I skip a question in here? Yes, I did. Okay, that's 55. Eli lives 3 3/4 miles from the library. So that's our illustration right there. That's what it's talking about there. We have his house here, a library here. There's a distance. There's nothing else going on there. The words confirm that. Eli lives 3 3/4 from the library. He decides to bike from his home to the library to return some books. So he's going to go this way. Okay. He biked 1 1/10 mile. So he goes 1 1/10. Okay. When he remembered he had left the books at home. So we stop there. We're here. So he bikes back. So now he's going to go back 1 1/10 again. So far, he's biked 2 2/10 miles. Okay. After getting the book from home, he bikes straight to the library. All right. So to be clear, he starts biking to the library, he goes 1 1/10 mile. Okay. He decides after 1 1/10 mile that he left something at home, and he returns home. So he did another 1 1/10 mile, right? Okay. So that's 2 2/10. Okay. And then when he gets home and he gets what he needs, he goes straight to the library. So now he's going to add 3 3/4 mile to it. Okay. So now what we have to do is get a common denominator between the 10 and the 40. Okay. And the common denominator in that case would be 20. All right. So what we need to do is convert this here. Gives us 2 and how many 20ths? Okay, it'll be 4. We're going to multiply the denominator by 2 and the numerator by 2. Okay, same, we're going to add 3 and we get 20 down here. So how do we go from 4 to that? We multiply by 5, so we're going to multiply the numerator by 5 as well. We're going to get 15. Okay, so then we have 2 and 4 20ths plus 3 and 15 20ths. We add the fractions first, so we get 19 20ths. Okay, 3 plus 2 is 5. Okay, so what I did not do, I did not explain how to get the common denominator 20 here. Okay, I think that's beyond the scope of what I'm trying to do here. If anybody's confused about that, please email me and contact me, and I could probably help you out that way. Again, I'm a tutor. I do tutoring. Even though this session is free, everything I do is not free. Everybody has to make money. So that's kind of where we're fitting in with things like that. So I can only say so much. There's hundreds of hours of videos and hundreds of videos I have on this site. On that note, please like, please subscribe, please hit the like button. Yeah, right? Okay. So that's where we're going there with that question. And that's the answer they're shooting for. So this dealt with mixed fractions. It deals with fractions. It deals with mixed fractions. It deals with understanding the word question. So this is logic as well about how to go back and forth through the words and map them back into the English and so on. All right. And common denominators is the big thing on this problem. So I'm not going to give a mini sidebar on how to do common denominators right now. All right. Okay, 57. Let me try to see if I can tap into this. Yeah, my tablet looks like it's almost ready to go. So we have 2 more questions, I believe. Let's see how we can do here. So we have a word question here with a lot of numbers flying back and forth with it. So we're going to take this one sentence at a time and see where it gets us to. Just let me make sure we're still good on the recording part of things? Yes, we are. Okay, so there are 12 players on a new softball team. Cool, awesome. Before the team starts playing, the team must pay for a total registration fee of $572, along with the registration fee, which means in addition to, as an addition, the team also needs to spend $1,240. So I already read the question and I realized that I need to add these two. Okay, so that's 2, that's 1, 1, 6, 8, 1. So this is the total cost so far. All right, so let's reword the first paragraph. There are 12 players on a softball team. Before the team starts playing, the team must play a total of pay $572, and then in addition, they must also spend, which means they have to pay for a $1,240. So the total cost of setting up the new team is that, okay? To pay for the cost, the players held a car wash and raised $768. So if we remove from that, because they have that money, we can find out how much money they need still to get. So this is a killer for some students because of the borrowing. We're going to cross this out and make this 0, and that's 12. So that's 6. 12 minus. We have to borrow a second time. Okay, that's 2. That's 0. So we get 1026 that they still need. Okay, that's they still need 1026. So if we continue, and we're right here right now, okay, they then decided to sell candles for $9.50 to cover the remaining cost. What? Okay, so it means that this is the remaining cost still needed. Remaining cost. Okay. If each player, we know there's 12 players, if each player sells the same number of candles, how many candles must each player do? All right, so what we need to do is take the amount they still owe, the 1026, okay, and we're going to divide that by the 950 to find out how many candles are needed. So as in before, we don't want the decimal on the outside, the divider. We're going to move it once. To do that, we have to add a 0. Okay, so what we can get is 95 divided into 10260. All right? So 95 goes into 102 once. We're left with 7 left over. Okay? 95 goes into 76. It doesn't do that, so that's 0. And 95 goes into 760 now. So 10 times 95 would be that. Since there's a 0 here, I'm going to not try 9, I'm going to try 8. Okay, 8 times 5 is 40, 0, 4. 9 times 8 is 72, plus the 4 is 76. Bingo, we got it. So this is 108 is the number of candles that they need to sell at $9.50 each. Okay? Now the question is, if each player sells it, how many candles must each player sell? So what we really have now is 12. We know there's 12 players into 108. And this is your basic multiplication table, right? It's not 8. Is it 9? Yeah, it's 9. Okay? And that's your answer. Booyah. Yeah. Okay? So this was really a multi-level question and problem. It involved an addition. It involved a subtraction involving a weird borrow. Then it involved a division. And then a second division. So this is basically a 4-step problem. And it's nasty. It's definitely nasty. If I'm not mistaken, this was worth 3 points on the test. The other show your work problems normally worth 2 points. All right? And just to be sure, if we come down here, right, they're looking for candles per player. So I pointed this out on some of the other things. We like to use the units on the answer to guide us, but sometimes it doesn't have all the info we want to have it. So, but at least it's better than nothing, okay? Because you don't want to put 108 here. The answer is not 108, okay? Can't do that, okay? All right, so at this level, some of these are so involved that we don't want to get too bogged down with all these kind of things like this. And the problem we have is there's so many steps to this that it's almost impossible to kind of double check it. And it's so easy because there's so much arithmetic going on to make a mistake. So you want to be careful. So this was involved the multiplication table all over the place, and involved basic addition and subtraction all over the place, and involved a multi-step word problem, and involved operations. It also involved equal parts again, because there's 12 players. There's we had to figure out how many candles were involved across the amount of money they owed, right? It turns out, so we got no decimal numbers. Like 108 was a whole number, and the 9 was a whole number. Okay? So there's 108 equal candles at $9.50, right? And if we have to multiply that all back out, basically the 9 times the 108 times the 9.5, right? We should get back that 18, we should get back the 1026. Okay, so that should equal 1026 if we were to do that. Okay, and that's partially a way to double check it all. Once you understand what all the words are really meaning, you can kind of backwards it a little bit. And of course, if you add the 572 back into that, you can prove that you get back the original 1240 here. Okay, and so on and so on and so on and so on. All right, so that's that. And let's see if the tablet holds up. If not, I'm going to end the stream. It's probably keeping us going on a mercy mission here. So we have an illustration about milk produced by cows. There's types of cow. There's a Jersey cow and a Holstein cow. And then on this side, there's two people's cows, Hank's cows and Deborah's cows. And they're producing gallons of milk. So at least in terms of the chart, the units are all the same. It wasn't like they're comparing gallons to pints. And just it seems to me that Deborah's cows are producing more milk than Hank's cows, both the Jerseys and the Holsteins. Okay, so I don't know what else to grok out of the table. So let's go to the words. Hank and Deborah each own 2 milking cows. Cool, awesome, radical. One day they milked their cows and compared the amount of milk the cows produce in that day. Okay? How many more gallons of milk did Deborah's 2 cows produce on that day compared to Hank's 2 cows? So it seems to me that we need to add up Deborah's and get something, okay? And add up Hank's and get something else, okay? So we can kind of do that down here. 5.5 plus 5 2/3. Okay, we need to get a common denominator again. So I'm not going to explore how to do that in this, but it's 6ths. So the whole number part is going to be the same. Okay, so 1/2 matching to that gives us 3/6, and 2/6, 2/3 will be 4/6, and if we add those, we should get 10 and 7/6. Okay. Since this is top heavy, the 7 is bigger, we can map it into 11 and 1/6. Okay, so that is Deborah. Okay, and then Hank is 4 3/4 plus 4 1/8, and we have the same dilemma. We need to get common denominators. So 4ths can be 8, so we're going to leave the 4 1/8 alone, and we're going to map the 3/4 into 8s. So I multiply by 2, so I multiply 2 in the numerator, I get 6. So if I was to add that, now I get 8 and 7/8, right? Did I do that right? And I'm just going to reread the her question, and hopefully the tablet doesn't die on me in the meantime. Hank and Deborah each own 2 milking cows. Cool. One day they milked their cows and compared the amount of milk the cows produced in that day. Awesome. And I can see that in the chart. How many more gallons of milk did Deborah's 2 cows produce on that day compared to Hank's 2 cows? All right, so what we need to do is, since Deborah had more, we're going to go 11 1/6 minus 8 7/8. And before I do that, give me 1 second, because I want to make sure those two numbers are correct. Okay, they seem to be. So what we're going to do is convert. We have a comma denominator scenario again. So we're going to convert those to 24ths. And again, that's an exercise by itself. By the way, I have videos in the past. You'd have to search for them. I can't really tell you where they are about finding common denominators. In particular, it deals with least common multiple and greatest common factor and stuff like that as well. So anyway, 8 times 3 is 24. So 7 times 3 is 21. And then with this 11, I'm going to get that into 24ths. So that would be 4. Okay. Okay. I can't subtract the 21 from 4, so I have to convert this again. The 8, 21, and 24ths I can leave alone. So what I'm going to do is borrow a unit from the from the 11. So 1 is equal to 24 24ths. So this becomes 10 and 28 24ths. Okay, right? We borrowed 1 from the 11 to make it 10, and 1 is equal to 24 24ths. So 24 24ths plus 4 24ths gives us 28 24ths. Just to make clear, that's a 24. So now I can do the subtraction. So 28 minus 20 gives us 7 24ths. And 8 minus 10 gives us 2. So we get 2 and 7 24ths. That's the answer. All right. And it would be in gallons. So let's just make sure that, yep, and that's where they're telling us is cool there. So again, this is dealing with fractions. This is dealing with addition and subtraction of fractions, in particular mixed fractions. Okay. Just I'd like to make one observation that I converted. Let me change to whoops. Let me change to colors one more second to make a point of something. So I converted this here to that. Okay. And then let me change the color one more time. I converted the 11 and 1/6 to 11 and 4 24ths, and then converted it one more time. Okay? And I'm pointing that out because there's sometimes where you don't have to do all the conversions. Okay? So if I kept it as 10 and 7/6, let me show you what I'm talking about, why I'm pointing this out, minus the 8 and 7/8. Okay? If I convert them to the 24ths, so I'm going to get 10. If this is 24, that's times 4. That would give me 28 24ths. And this is 8. And if that was 24, this would be 21. Okay? If you notice, we can straight up now do the subtraction. This is 2 and 7 24ths. So instead of converting the 10 and 7/6 to the 11 and the 6, to the 11 and 4 24ths, and finally to the 10 and 28 24ths, if you notice, that's the exact same number as that. Okay? So that's hard to observe when you're solving these problems, but in hindsight, you can start detecting these, and as you start getting more fluid with the math and familiar with it, you're like, oh, I don't need to do that conversion twice, right? I needed to convert this 10 and 7/6 into, because it was top heavy, to get rid of it as top heavy, make it a normal fraction, into the 11 and 1/6. What I'm trying to say to you guys is sometimes you don't need to do that conversion to simplify it into standard mixed form. All right? Sometimes you just leave it alone to find out where the problem's going, right? And if you found out when you did the subtraction that you were going to get in trouble or whatever, or it was more going to be hotter, then you can convert it. All right? And it's on this, and this getting the 10 and 7/6 was a slight hint that that might be where the question is actually going into. All right. All right. So with that note, hope you all have a good day, and peace out. We're going to do grade 5 part 2 soon. Bye.